Thank you for our panelists for joining us today. So kind of the context for this conversation is as our AI outputs guides decisions made in the industry applications it's applied for, like in finance, like in healthcare, in defense, in governance, the question really shifts from what did the model say to can we trust it? What was it supposed to say? Kind of aligning the intent of what the model is supposed to do and its actual behavior. So today's panel will focus around these aspects for how we can go about with verifying our AI-based systems and some potential tools, like for example with zk and how it can help with that verification process. So first off, I'd like for all of our panelists to go and briefly introduce themselves. Starting with Ismael.
Yeah, so good afternoon, everyone. My name's Ismael. I'm one of the co-founders of Lagrange Labs. And we're a company that focuses on the intersection of AI and zero-knowledge proofs. We build a library called DeepProve, which is the only production-grade and most performant library available for zk machine learning today. And we have a fantastic research team that tackles problems like verifiable inference, as well as many ancillary ones, things like proofs of non-hallucination, as well as proofs of fairness.
Hey everyone, I'm David Liberman, creator of Gonka. Gonka is decentralized AI compute network. Every inference on the network provided to developers is immutable, inherently immutable, verifiable, so we can trust actually what model says.
Hi everyone, I'm Daniel Kwak, the CMO at Laz AI. We do basically everything in AI. If you want to launch an agent or monetize your data, we can help you track your dynamic data. We have AI agent framework, and most important, we have a launchpad for you to come launch your token on. So yeah, thank you.
Hi everyone, I'm Viglione, the CEO of Horizon Labs. We're the core builder behind zkVerify. Like I said on the panel earlier today, we have cool stickers back there. Please come check them out. But yeah, we've been in the business of zk for a while, the last 8 years, and zkVerify is hopefully contributing to this particular space at the pure verification layer.
Thank you very much for all of the introductions. Starting off kind of broad and really focused on the main motivation, the main why as to why we're doing this. Wanted to hear from all of you what the real need is to verify our current AI systems, especially, for example, say, proving the inferences from a model or proving that the outputs are as expected, especially when, for example, a lot of the models that we currently see act in this black box environment where we aren't really sure what's going on underneath the hood. We can only see, what goes into the model, the inputs, as well as the corresponding outputs. So wanted to hear from you all what the real need is for verification in our AI systems.
I'll leave it to these guys to kick it off because I think they should all be zk verified.
Yes, so in general, we already observed two major shifts brought by blockchain. First was introduction of immutable ledgers, when we can trust the transaction would happen. No one can stop it. No one can interfere with it. Governments or richest people in the world, they cannot affect it. Then we saw the same with immutable compute, with introduction of smart contracts in Ethereum. And now it is the third major shift, when we need to build the infrastructure for immutable agents. These type of systems will act on our behalf. We cannot just leave it as it is, run by corporations or influenced by governments. We need to have the way for it to be immutable as well. The same way as we run smart contracts, now we need these agents to act and to do financial transactions or to any type of business transaction for us. Like immutable smart contracts, they allowed legal system to be on chain. But immutable agents will allow us to run bureaucracy as a whole on chain. So we need to have the way to trust it without trusting any particular source.
Yeah, so it's a great question. I think it's important to always ask why on most things in life. But crypto has this problem, very broadly speaking, that most of the technology sector for the last 10 years in America has had. And that is an obsession with building incremental solutions to non-problems. And this is why we have 40 teams building chat apps. This is why we have, hundreds of crypto teams trying to build consumer roll-ups, and really very few people tackling problems that I think are fundamental to modern technology, right? It isn't fun to solve something that's intractable to an industry. It's fun to try to make a small tweak to a successful business and hope you can monetize it by capturing a portion of the existing demand. And so that's why you look at AI today and you say, okay, AI is being used in everything from autonomous weapons to healthcare decisions to institutional finance. And yet there is no way to assure that the correct model is being used in the correct contexts. There's no way to guarantee privacy naturally over inference. There's no way to guarantee a model isn't hallucinating. And there's no way to guarantee that the model is fair, right? That we've run the model over a sufficient number of inputs to determine that there's no inherent bias in how the output is constructed. And we're willing to just keep building things that are incremental instead of going after those problems. The core verifiable AI is building closed form mathematical solutions to those problems, right? It's not slapping a consensus on an LLM and claiming that now you have verifiable AI. It's designing fundamental solutions using mathematics and cryptography to solve issues that are intrinsic to AI. That's what we do at Lagrange. The first thing that we built was verifiable AI for inference. You take a model, you parse that model into an Onyx file with a bunch of modules, and then you can prove the correctness over a quantized version of that model. So you can now use that model in the drone in a security conscious setting, and you have assurances over the correctness of it. Now there's a variety of other works we have coming out that are extending that to support privacy over both closed source models and proprietary data, as well as extending that to being able to formally prove fairness, as well as non-hallucination. And we think that these are the types of things that companies have to tackle for the industry of crypto and cryptography more broadly to actually have, true PMF.
Yeah, great question, and I completely agree with these two. They're brilliant answers. And to build on that, I mean, if you just look at how AI is built, right, then exactly like you said, the kind of how AI is actually coded is it doesn't care about verifiability at all, right? It's just not built into it at all. And that allows basically companies to build a complete black box, because it's not just that they're not accountable, it's that they can't really be accountable, right? Just by how they're run. And if you look at your answer, it's really, if nobody's doing it, right, then you don't really expect it either. So at the end of the day, it's, do users expect it? And does that actually make a marketable difference in basically how well they sell, for example? And by having a system that allows you to actually verify, then you can actually get real value into the actual system if you look at agents that are making actual work outside of just chats, right? So for example, if it's a medical agent, if it's a Deep AI, if it even hooks into TradFi, then all of their decisions or even recommendations would have marketable impact on the actual users, and even have calamitous consequences if it actually goes about it in a really terrible way. So at the end of the day, it's important for us to have these systems that track it, not just so that I can track it, because at the end of the day, how many of us are actually going to go look up the proofs that are going to come out of this? It's, if you do it his way, then by nature, it is verifiable. If you do it some other way, then you are allowing that accountability to happen, which forces the businesses to adhere to whatever ethics that they think is their bottom, right?
Why not? A little louder than I thought. So guys, I think where this is going to play an even bigger role is when we get into more black box type systems. And I'm not talking black box of a model itself, but when models are run on a black box, like a hardware enclave or some sort of like TE environment, especially for use cases like national security, healthcare, areas where you just need privacy to what you're doing, or just pure segmentation of it. Then verifying that in some way is going to be even more important. And clearly, you're not going to look up the proof yourself, but you'll have some software that just references it, from somewhere else. I think that's how we look at it, and that's where we hope to play a role.
Thank you all for your insights. First, David, on categorizing those different shifts and now how we're emerging into this immutable agents focus right now. And then even for Ismael, the current work that Lagrange is doing with Deep Proof and your guys' approach for finding that PMF. And then Daniel and Rob, your insights as well. So thank you for that. And I now want to ask about some of the specific parts of the pipeline that you all believe should be prioritized in terms of verification. So should it be on the inference level? I know, Ismael, you mentioned that for Lagrange, one of the first use cases was being able to prove these inferences. So would it be based on the inferences, the model architecture itself, inputs and outputs? What parts of this pipeline should we really be prioritizing for verification? And like, for example, say with a higher stakes related industry, like even with defense or healthcare, for example, should we also be prioritizing the verification of the inputs and outputs in addition to the inferences as well? So which parts of the pipeline do you guys really believe we should be prioritizing on?
We at Gonka, we decided to prioritize adoption. So today, the major shift happens more and more people in the world use AI. Really, billions of people use AI. And if we are not there right now in their major use cases, we will lose it towards these black boxes. And that's why, even though I personally truly believe that training, for example, is really important to make verifiable as well, but we need to solve inference as soon as possible, because we need to educate people that they can have this kind of privacy, they can have this kind of trust. And then the rest will be able to build on top of that. So from this perspective, by having the ChatGPT type of experiences or Cursor type of experiences run in decentralized networks, I think it's crucial right now, because it will educate all these users that they can have this type of trust in the systems, and then we can offer it for national defense and the rest of the world.
Yeah, so I think, once again, adoption is very important for any technology. The problem is the architecture that you use to get to that adoption, right? Do we think that Raytheon is going to grab a Tendermint blockchain with some TEs and use that to secure, the next campaign? No, I mean, it's just, you're not going to be able to actually reach adoption of cryptographically secured AI if you don't build cryptographic systems that can easily be integrated into existing architectures. If you're using a blockchain to secure AI, the application of that is substantially limited. Now, this is back to your question of what you should actually be verifying with cryptography. And yes, inference, I think, is the North Star first step, right? If you can't prove inference, you're not going to be able to prove fairness or training. These are all problems that predicate on actually the code of being able to prove inference. And then beyond just proving the correctness of an output, there's several other things you want to prove about inference. I mentioned non-hallucination previously, which is very much an open problem. Another of these is fairness. How do I ensure the model doesn't have an inherent bias at the point of training? How do I have a formal property that inference, in fact, abides by some, human recognizable concept of being fair to the input set? And then from there, you get to things like fine tuning, which are computationally less complex than things like training. And then you finally get to training, which is an incredibly computationally intensive task and probably will not happen for the next 30 years in a verifiable way, given that training, Grok 4 costs hundreds of millions of dollars, if not low billions of dollars. And the idea that you're going to have a 2x overhead on that to run the whole thing through a prover is a little far off. But the immediate problems are inference, and then there's things that are ancillary to inference that will soon be tackled as well.
Yeah. Again, I mean, you said two brilliant people to my left, so I can only follow up. But to have a slightly different take on it, right? While I do completely agree with all they said, you'll also kind of have to look at who is this for, right? It goes actually exactly to what you were saying. But if you look at who it's for, then let's be honest, I'm probably, again, not going to look up the proofs of whatever the inference was, right? At least not that much. Right now, if you look at ChatGPT, probably one of the biggest uses I think I saw was that they use it as kind of a more enhanced Google search, right? For me to look up what kind of food dinner I can make with the ingredients in my fridge, I don't really need a verification, right? I don't need it to be proofed. But if it was, say, exactly like you said, Raytheon was using it, then absolutely I want it to be proofed. Even if I'm not the one using it, I want them to use something that's proofed, right? So if the agent that's using the proofs is, say, really just simple, consumer day level kind of things, like what's in my fridge, then yeah, inference proofing is more than enough, right? But the higher you go, obviously, the more involved it needs to be. And exactly like you said, even just building the models itself in a provable way, that completely changes the kind of value proposition that it would have for specific market segments.
All right. I'll take it in a slightly different way, guys. I'll talk about the artifacts of AI because I'm not an AI guy, so we'll leave that to the smart guys here. But when you have agents that are operating in environments that we care about, and I'll give you some examples with some of our customers. So say you've got a dark pool, for trading assets, and you've got agents that are automated to operate within that dark pool. That's a great black box, guys. In that type of environment, you absolutely want, or could certainly make use of, a variety of proofs interacting in different ways to make sure that that agent is actually doing what it's supposed to be doing, and that you can actually have verifiable outcomes that you can check in some other public environment based on what happened in there. So that's the kind of area that we actually find really interesting right now.
Got it. And yeah, thank you all for all your insights. So for Rob for presenting that use case, and both you, Ismael, and also Daniel for really focusing on like which specific use case can verifiability be applied to. You both mentioned, for example, Raytheon. We would definitely want to have verifiability attached to that, but maybe for some other day-to-day operations, it may not be as appropriate. And all of that really comes to fueling the adoption standpoint that David, you mentioned. So thank you all for that. And I wanted to transition this conversation into the types of mechanisms that we can use for verifiability. So Rob and Ismael are both focused on the zk aspect, so using the verifiable compute use case of zk. But then I also want to hear from David and also Daniel on some of the other kind of mechanisms that we can consider in addition to zk for verifiability.
Yeah, I guess I'm first. So for us, because verification was not the core reason why we started our company, we had to look at how does their verification fit into the whole pipeline of basically data all the way to actual inference. So for us, we kind of had the luxury of taking our pick, and we ended up basically taking all the picks if we could. So we combined basically ZKs, we combine OP and TEE, and we even have an engagement, user involvement aspect to it. So exactly like they said, it doesn't make sense to verify everything from start to finish. So for us, we look at a data source or a model, and we have to look at what makes sense in this specific instance. So if it's a simple inference for a simple, easy output, then you can just get away with, say, having an OP proof just to get the inference out quickly as possible, right? But if it's a bit more involved, especially for things like deep AI, then you might want to get zk involved. But again, you have to look at, okay, if this is a high frequency trading deep AI, then maybe zk might take a little too long for it because it needs to execute, I don't know, dozens of times in a second. If that's the case, then you can also look at batching those and then putting it through a zk. But then you're verifying after the fact, and that might still be okay, right? So we're giving the luxury of freedom to all of the agent developers and the data source, I guess, controllers to be able to see what fits kind of their model, how they plug into LazAI, and for us to say, this is the bare minimum, and that's basically you have to have some type of proof that you're logging on to LazAI, because exactly like we said, we don't want non-proofed AI. But again, going back to what I said previously, sometimes it makes sense to be more proofed than others.
Yeah, so the way I see it is like this. When you start a company, you have to ask yourself, I'm going to spend the next 10 years of my life doing something. What am I going to be doing and why am I going to be doing it, right? A lot of young people, and the great thing about crypto is all the young founders, but a lot of them, they'll start their company saying the thing I want is money, right? I want to make a bunch of money. But you quickly realize that that is a very vapid and empty way to live your life and to progress your career. What you need is something beyond that. Something that you can say, okay, for the next 10 years, my contribution to this field is meaningful, whether that be a scientific pursuit, a commercial pursuit, something, right? And so the question of what you're going to be doing to prove AI should be the question of what is the correct solution to this problem. Not what can I build to be able to turn a buck and buy a nice car and a boat, right? And so the only way to ensure that an AI system operates with guaranteed correctness is through cryptographic security. That is through zero-knowledge proofs over the inference to secure the computation, and that is through a combination of zero-knowledge proofs and fully homomorphic encryption to ensure that there is privacy over the inference. That is the solution, full stop. You can go to any professor, any cryptography researcher and say, if compute was unbounded, if time was unbounded, how would you solve this problem? And that is the solution you would hear. So if the answer of what you're going to be doing for the next 10 years of your life is anything different than that answer, I would seriously consider changing the answer. Because you shouldn't be dedicating, or at least I don't think you should be dedicating, that much time to something that is not directionally correct. And so for this problem, and with what Lagrange does, we target that end. Deep proof has been our first step. Proving AI inference using zero-knowledge proofs for a variety of commercially viable and frontier models. Very soon that will include hallucinations, or proofs of non-hallucinations. Very soon that will include proofs over encrypted data. And 50 years from now, that will hopefully include proofs of training.
We do admire the work which is currently done by zero-knowledge proof community. And one of the biggest miners in our network right now is 6blocks. They were great contributors to zero-knowledge proof. At the same time, we think that we currently in this crossroad. We need to act right now to make it possible that AI is not controlled by major AI labs like OpenAI and XAI. It cannot be done in 10 years from now, it should be done today. And for that, we need the solution which can be applied today for large models. Most of the developers, only fraction of use cases can be actually implemented today with models of a smaller size. Most of the developers use models of 400 billion parameters, 600 billion parameters at least. And for that use cases, we need to introduce already today, while the science is developing toward that, we need to introduce solution which can work today. And even though Bitcoin called a cryptocurrency, cryptography, but cryptography, as we all know, plays quite a tiny role in Bitcoin. Bitcoin solved the only problem, which was double spending. And to solve this problem, consensus solution, voting, was introduced. It just to use a proxy of one human, one vote, Satoshi introduced the idea to use one CPU, one vote. And the same principle can apply today for AI verifiability. Because the same GPUs and then ASICs in the network can represent the consensus, can represent the votes. And from this perspective, this verification can be just fraction of the compute power dedicated for inference. And this type of solutions can enable those use cases already today and can actually be competitive, like we've seen with the rise of different BitTensor, for example, subnetworks in Open Router. They just crushed the competition. Companies like Nubius or CoreWave, they are out of competition. They cannot compete with decentralized technologies already today. It's not like, in crypto seems to be lacking behind in terms of this massive use cases, but it's actually not. It's already today outpace the competition of all the other GPU providers in the network, providing the inference for open-weighted models. So we see enormous opportunity to use consensus, like in case of Gonka. We do believe that the consensus should be proof of work consensus, the same way it was implemented in Bitcoin. And for sure, we need to invest more and more in science of zero knowledge proof to make it possible for the future to be fully verifiable, available for everyone.
Next question. I don't know. Agreed. Yeah.
Yes, we did. Yes. And thank you all for your points over there, especially with Ismael, how you kind of categorized Lagrange's journey into first proving AI inferences, and then potentially later on, you're looking into proving hallucinations and eventually training as well. So there's quite a few different areas of the pipeline that the team is working towards. And to your point also, David, when you mentioned about how we really need to target those use cases that developers are working on right now, and for example, being able to handle these models with billions of parameters. And even Daniel, you mentioned a bit about the use case part, like for example, how LazAI provides the flexibility for these different verifiable mechanisms, especially for a use case you mentioned with a high frequency trading in which you can't really afford to have extra latency attached there. I'm curious to hear from all of you the current technical barriers that we have with enforcing these verifiable mechanisms. Like for example, can we eventually reach a point where we can prove a model with billions of different parameters and even some other types of verifiable mechanisms? Is there any kinds of ways in which we can optimize the overhead that's attached to using them?
I mean, I'll open it up with, so for us, we're tackling the technical barrier of scale. honestly. So it really depends of how many proofs do you expect to be generated in the market and for what, really. So I'll leave that to these guys to figure out what needs to be proved and at what volume. But we are building for, currently we're handling hundreds of millions of proofs in our network, and we need to be able to handle billions and tens of billions. And ideally, I think we need to even go beyond that. And right now, I would say that that's probably, from our point of view, a major technical barrier. Totally tractable, though.
What he said.
I actually believe that for inference, we're already there. For training, it definitely will be a challenging project because we will need to grow the networks, talking about scale, to hundreds of thousands of top GPUs to make it possible to compete and to introduce to the market those big language models which will be trained in open way so that everyone can actually see what is there. You know, like we can be sure that inference provided is exactly the one which we expected by the model, but we cannot be sure that the model itself is not infiltrated with the thoughts which we don't want to see from the agents which act on our behalf. So, when you ask an AI some healthcare question, you don't want to think about whether it's advertising or not. You want it to be trustworthy. And from this perspective, for sure, training will be a challenge. We'll need to gather actions from probably hundreds of different research labs around the world. But we are quite hopeful. We see most of the, a lot of great scientists around the world. Only through the last 2 years, probably, at least a dozen major articles were released improving the capabilities of decentralized training networks. So we are quite hopeful that those barriers will be solved, but it definitely will require a much higher scale than the networks which we see today.
Right. So let's talk about the math of it for a minute. So Lagrange's deep proof is currently the only production grade library that can prove zero knowledge inference over LLMs. We've been able to support models ranging from about low 10 figures, so several billion parameters, including things like GPT-2 and the larger version of that, Gemma 3, which we announced today, Llama, and a variety of other production grade architectures. So the answer for inference is yes. The question is overhead, right? Because to prove something with zero knowledge proofs is a computational overhead. Generally, we've seen this overhead come down by about 1 order of magnitude per year over the last 4 years. That's consistently been true across rollups, zkVMs, et cetera. This comes from faster arithmetic, better engineering, GPU acceleration, distributed proving, and just improvements in kind of compute per Moore's law overall and access to compute overall. And so we're right now about 2 orders of magnitude off from what I'd consider real-time proving for LLM inference in the low billion parameter range. So yes, we're very, very close there. And from some of the non-hallucination work we're doing, we're looking at about a 10 to 20% overhead on top of proving inference. So the answer to that is yes as well. That's well within strike zone. We're probably 3 to 4 years away from being able to prove really any arbitrary machine learning model at approximately the same compute overhead as running that model natively. And that's going to be just a massive breakthrough, right? You're talking about an acceleration of innovation in cryptography that I'd say is on par with the performance improvements we saw with TLS in the 1970s and encryption in the 1970s. And so, yes, we'll have that for inference very, very soon. We'll have that for proofs of non-hallucination, obviously subject to innovations and research in proving non-hallucination, even without ZK. And we'll have that for fairness as well shortly after. Training and fine-tuning will take a little bit longer, but they are coming. And once again, like you're talking about a transformational technology that is already compute constrained on just running it outright. This is an immediate solution in a variety of verticals, things like defense and healthcare, where there's an incredibly high economic value predicated on top of the results of these inference. It really isn't a pressing issue in most consumer LLM usage, given that the open source models aren't even competitive in most cases with the closed source models. So I'd like to see advancements in kind of open source model development actually take off before we start, arguing about the most, privacy preserving way to use them. But yeah, and to summarize everything, we're very quickly approaching the convergence of verifiable AI through ZK and just AI broadly.
Yeah, so definitely seeing a lot of optimizations and orders of magnitudes even of improvement over the last few years.
Yeah, and it's only accelerating, right? Like we've seen at least an order of magnitude in the last 8 months since we launched DeepProof, 6 months since we launched the first version of DeepProof. We changed up the PCS that we're using. We're adding GPU support. We added parallelization. I mean, all of this stuff is I think somewhat commodity engineering at a point, and couple that with foundational research innovations, and you're able to really eke out over an order of magnitude per year on this stuff.
Yeah, so the age of verifiability is finally here. And I think a very common theme that was discussed about along all of our panelists was the importance of targeting whichever verifiable mechanism that you're using to your specific use case. So whether that be privacy related or whether that be if speed matters or if that latency is a concern, or even just differentiating against those high stakes scenarios like with healthcare and defense versus some other applications like say that are on-chain or blockchain based. All of those use cases need to have some sort of tailored structure for these verifiable mechanisms to be applied upon. So thank you so much, everyone, for all of the insights and for joining the panel today.
Thank you, everyone.